Caddis Maximus here, this time doing a review of one of these easy to read power voltage power supply testers. These testers have been around for a few years now. They're made by a variety of manufacturers. They've changed the case. Either some manufacturers use a different case design or they've kind of modified them to be a little bit more sleek. However, they're the same tester. I used to be involved a lot with computers, nowhere near as much as I used to be. I actually don't even have a computer right now besides the phone. But I do like these computer power supplies, particularly the server ones, because I'm always working on electronics and it's handy to have high power 5 volt and 12 volt power supplies, and even 3.3 volt. The neat thing about 3.3 volts is many white LEDs you can drive just straight off to 3.3 volts. So it's kind of handy. And so versus, you know, in the world of computer gaming and all that kind of stuff, there's these big time, you know, 1,000 watt, 1,200 watt, etc. power supplies. But it used to be when you really wanted a big power supply, you need to get a server power supply. And even now, I by far recommend server power supplies over any type of gaming or desktop power supply because they're designed to last a very long time. Designed to continuously operate at months on end at 100% full output, and they're very intelligent by adjusting the fans and being able to protect themselves if they have any kind of issues. They have a variety of warning lights on them, or some warning lights like this one it has 2 colors and will blink on and off depending on what issue it may or may not have, whether it's not connected or something like that, which is really nice. It's all short circuit and overload protected, so that's also nice. Doing automotive stuff, which is one thing that's kind of nice about these, is obviously you can't run a starter even off of a big power supply, but you can plug it into a car's electrical system and test lighting circuits, test power windows, those kind of things, and it's actually made them quite handy in those situations. The only thing to make note of is some power supplies split to 12 volts among multiple different rails, such as this one where you'd have a 12 volt, like an 11 amp for this, another 11 amp or 14 amp for this, and then these drive connectors would have yet a third separated power rail, and that helps prevent noise from maybe the motherboard or some noisy drives or fans from polluting power that's going into the motherboard. And that's only to a degree. These switching power supplies are immensely noisy, especially compared to, say, a electronics test power supply like this. This will have 0.003 to 0.005 or 3 to 5 millivolts of ripple or noise, where this computer power supply under even low load will have 1 to 200 millivolts, and fully loaded it could pass 3, even 400 millivolts of ripple, which is obviously 100 times more noise than a benchtop power supply. And the real amazing thing about computers, and what has even enabled modern computers, is switching power supplies, because you couldn't have big linear power supplies. Your computers would weigh hundreds of pounds. But for that sacrifice in efficiency and being compact, they are very noisy. And computer electronics have all sorts of circuits called voltage regulators, which actually clean up the remaining level of noise before any actual microchips encounter it. Anyway, it's always nice to test computer power supplies, since I always buy these things used when I find them for $5 or $10 or something like that. They are really awesome. And they're actually kind of hard to find. It seems like the electronics retailers, there's a big era, say late 2000s and around 2010s, you know, up until a few years ago, where they would just, you know, shred apart all sorts of servers and other stuff and just and then just sell the components. And now it seems like there isn't a market for it. It's all sent off to recycling, and I hardly see any of this kind of stuff anymore, which is a real shame. This one right here that we're working with is a Delta 500 watt. This is a non-redundant, but it is a server power supply. It's for one of those thin servers where they just don't have room for redundant power supplies. But it is a really nice. Deltas are really nice electronics. They're, of course, very cheap Delta fans and Delta power supplies, but Delta is known as being the premium manufacturer of computer fans and power supplies. That is no joke. Someday, I mean, I have a huge collection of server fans, probably over 100 of them. Some of these fans are small computer fans, but they are 40 and 50 watts and move hundreds of cubic feet of air a minute. They're really insane. I even have fans that are 8,000 and 10,000 RPM. all by Delta Electronics. They also hold the highest number of patents for blade designs on fans. I can even see from the sticker down here that this came from a Hewlett-Packard server. One thing about these power supplies is, like many switching power supplies, like little power bricks are just, say, 100 to 240 volts, but it seems like computer power supplies, they actually separate that out from 100 to 127 volts and 200 to 240. I've never actually tried one of these at a voltage other than that, but I do have a Variac, and I may make a little video about that at some point. Anyway, I've talked a lot about power supplies, and since I picked these up, I ended up finding one of these power supply testers and noticed that there's like 10 different brands of these things, and it's all basically the same unit. It has a nice blue backlit LCD display that I showed in the thumbnail, and we'll get that plugged in a minute. And what's nice is it has pretty much all the different connectors. We have an 8-pin here. If you want to test a 4-pin connector, you just put it in the one side of the 8-pin. 6-pin, we have the standard small Molex. We have the D-shell Molex, which is like the power supply connector in computers. We have one for serial ATA and those kind of connectors, and we have this, a main power supply connector, which will accept either 20 or 24 pins. So this pretty much will plug into anything. And it tells you all the important information you need, the various voltages, and then how long for the power good to show up. And that's a computer specific thing. On these power supply cables, there is a gray wire, and you can't even see that, but there is a gray wire. And one aspect of these power supplies is that when you turn them on, they take a minute to get their voltage up and then to stabilize. I shouldn't say to take a minute, they take a fraction of a second to do that. But instead of the computer trying to operate as the voltage is coming up, which could cause damage, they have what's known as a power good. So the power supply comes online. Once it internally reads that it has come up to appropriate voltage, it sends 5 volts out the gray wire, what is power good. I believe, hopefully I'm not misquoting on the gray wire. Maybe it's the blue. I always forget on those two, but I think it's the gray. Tells the computer the power supply is ready and the voltage is stabilized, and then the computer starts up. That's why when you hit the power button on a computer, it seems like there's just a fraction of a second delay, even though the power supply itself and the fans turn on like immediately. That's because at that fraction of a second where the power supply needs to warm up or get up the voltage, then tells the computer it's okay to start up. And another quick note I'll show real fast is if these power supplies, these ATX power supplies, many times don't have power switches, and even the many do, it doesn't actually turn on the power supply. This doesn't have any mechanical switch on it at all. And people are always confused. You can always turn them on manually very easily. The power switch is the green wire, and it is universal on these power supplies, the green wire, and you ground it out. Literally, like on this connector here, you just take the green wire and you connect it to any black wire, like one that's on either side of it, and that's how you actually get the power supplies to turn on. So I just have this little tester, and wanted to make a little review and just show how it works and how handy they can be, particularly for somebody like me who likes to work on various projects. Another note is you can connect multiple power supplies together in parallel to get huge amounts of amperage. I mean, you could easily stack up 100 amps at 12 volts running multiple power supplies and physically just linking the 12 volt wires. What ends up happening is one power supply may be a fraction of a volt higher output than maybe the one next to it, and it kind of does what's known as leading, or a lot of the load will be placed on it, and its voltage as it gets towards maximum output will start to drop a little bit, and that's where the additional power supplies running in parallel will start to pick up the slack. So you really can run them in parallel and achieve, pretty much the sky's the limit. Very dangerous amounts, thousands of watts at the 12 volt rail if you want, where you could get enough of these stacked together to turn over a starter. But it would be a bundle of wires like 2 inches in diameter, I'm sure. Anyway, let's take a quick look at this thing. There's one misnomer about this. It says anytime you want to test anything, you need to have a ATX or a power supply main connector plugged into it, and that is false. And I'll just go ahead and do that right off the bat. I have one of these little one of these little power bricks that's just designed like to test computer fans and other kind of accessories that use the full-size Molex or D-shell Molex, and it's kind of a neat little unit where it just does 1.5 amps out to 12 and 5 volt. Let's get this plugged in. Here we go. We got a green light on it. What's kind of neat about this is it also has a separate power switch where we can turn the connector on and off. And we can easily show on this little power supply tester And it was something that was mentioned in a few reviews that I read, that it won't work without this. And what happens is if you turn this on, we can see that turns on, is it won't ignite the display without the power connector, so it won't give you an actual voltage readout. But if you just want to test just a 12 volt or 5 volt output to see if it's working or not, it still will light up the green LEDs for 12 and 5 volts, so you can still use it in that fashion. It just won't light up the display. So I did want to, even their documentation on Amazon says that it must have the ATX connector, and you don't need it if you just want to do some basic testing to see if it's the voltages are actually being output. Let's go ahead and get this plugged into this big power supply here. Get that out of the way. I do go the extra mile. I have a special power cord like this. Many people have never seen a power cord quite like this. They are indeed a rare beast. You have to specially order them. It's a pretty thick cord. You might wonder why on earth it's only rated for 6 amps and why on earth this plug end is so large. This has an integrated electromagnetic interference and radio frequency EMI RF filter. So yes, this power cord has a built-in noise filter right into the plug, and I really do like that. It's kind of nice because these switching power supplies actually generate a bunch of electrical noise into your power lines, and so a power cord like this will help prevent that from getting back in there. So we're going to go ahead and plug in this power supply. And this is pretty smart. If it's not plugged into anything, it does turn on, but it blinks to let you know that something's going on, but it's not red, so it's not an internal power supply problem. Obviously, the issue is it's not plugged into anything. What's interesting is it's very smart. One of the fans doesn't even turn on, and the second fan only runs at minimum speed. And I did want to do another demonstration just to show the kind of how these really are meant for high continuous output. As we unplug it here, it's still running for quite a long time without any power plugged into it. This has a huge reserve in it. We'll go and plug this in, and how this works is you just take your little power supply tester. Let's go and zoom in just a little bit here. And they've cut off the little lock lugs on these connectors, so you don't have to worry about the little locking tabs getting seized, but you just take the unit and you just plug it straight in. And this, I'm going to let this power supply settle down for a second. These always run at full output, both fans on high, until it realizes that it's actually not driving a load, and then slows down. There we go, it's starting to calm down now. So when you plug it in, it just simply gives you your readouts. It tells you how long it takes for it to reach its power good level. Anywhere from 100 milliseconds to 500 milliseconds is good. We can see this is 340, so it takes a third of a second for this power supply to warm up. And then it'll just read out your various voltages, as well as 2 different 12-volt rails. It won't do 3 rails. This power supply does have 3 rails, but it at least does 2 of them. One thing to note, that if you don't have your second rail plugged in, it will read low and beep, but that's not an issue just because you don't have it plugged in. This power supply, if I can keep this in frame, it's a little awkward. Excuse me, it does indeed have an 8-pin connector for modern computers. So all you would have to do is take the 8-pin, plug it in simultaneously on the other side, so now it's both sides are plugged in, and we can see now it stops beeping and gives us an error, and we can see our negative 12 volts, a little bit low, but it's okay. 5 volts perfectly at 5. 3.3 volts is a little bit low. I've tried taking this apart. It's a little bit funky. We'll see at the end of the video to see if there's any way to calibrate it or adjust the test to make sure that this power supply tester is reading correctly. And then we have our 12-volt rails, which are showing that it's 0.2 high, which is just fine. There's actually almost no real load on this power supply. What is interesting is you'll notice that these green LEDs aren't lighting up because this display is dedicated for this connector and this connector. If we still wanted to see about the output of one of our drive connectors, such as one of these, we would actually have to plug it in addition to everything else that's plugged into here, like so. And now we'll get the lights for the +5 and the +12 volts, which I thought was kind of interesting, that these two lights here, or these three lights, are more dedicated just for those special connectors, but they don't actually test this the 8-pin or the actual power supply ATX connector. And that's what always makes this thing a little bit funky, is the fact that you don't just plug in one wire, you plug them all in, all at the same time to actually use it properly. The only caveat to that is, obviously, if I want to test an old floppy drive connector, something like that, I will say that the connectors on this unit are really, really tight. They will take a minute to break in. So if I want to test a floppy connector, I need to unplug the D shell so that those lights will turn off so that I can plug in the floppy connector, like so, and then make sure that this connector is actually working properly. Otherwise, these lights will light up and they won't tell you that maybe you have an issue with a terminal inside here, or maybe an issue with a terminal inside this part. So I also wanted to point that out. I did want to spend a second as well talking about these server power supplies. They do warn not to leave this plugged in for extended durations of time, because they say it may overheat, and I'm kind of surprised about that. But we did show how long this power supply likes to run without any load when we unplug it. And when I unplugged it, it turned off almost immediately. So surprisingly enough, this thing does use quite a bit of electricity. Alright, I'm going to get this cleaned up here and see if we can't take a quick look inside, and I'm going to chat for just a second about, when I said this is not redundant, for any of my subscribers who don't know, I'm going to mention and show what a redundant power supply is. So I'm not going to be able to open this up. They actually use two little clips that clip onto the little motherboard circuit board that's inside. And this is like ABS, this little cover here, so the whole board slides in through this side, and then this little cover kind of locks it in place. They're very easy to snap off, so I don't want to do that. I did do a very close inspection because you can actually see inside it pretty easily through these big gaps. And there are no potentiometers, so it is electronically calibrated, or self-calibrating, quote-unquote. I can say that instead of electrolytic capacitors, I was able to see the CAN-type capacitors, and they are what's known as solid capacitors, or solid polymer capacitors. They don't have a liquid electrolyte, and they are high performance. They're rated to last 30 years or more, which is a very good thing. It shows that it's a little bit more quality of a product when they're using what's known as solid capacitors, or polymer capacitors. And I did want to show what I mean is you can even convert these power supplies to actually be just benchtop 12 volt, 5 volt, and 3.3 volt, just utility electronics project power supplies. I actually took the little green wire and connected a switch so I can turn it on and off easily, and then ran it to all the terminals. And I was wise where I just took the whole bunch of the wires and put them all into a giant connector. That way I wasn't running into any voltage drop issues and used up a ton of zip ties. But this is one aspect. This is an older 300 watt Delta, but just the way the ventilation and grill worked, it made it very convenient for me just to set it all up like this to use a server grade power supply, a redundant one, as just a hobby power supply. And I have something that's very reliable. All those trip lights, the linear ones are great when you need low noise. If you don't need low noise, you can't beat a server power supply. You can't even come close as far as robustness. And to finish it off, you can see I do have a couple others which are a little bit easier to deal with and look at here. This one has a huge tangle of cables coming out of it. This one is a 600 watt. And we've got a 450 watt here. And what we have here is what is the two common types of redundant power supplies. One is known as a 100% redundant. One is known as a 50% redundant. And you might ask, what do you mean by 100% and 50% redundant? It's either redundant or it's not. And the answer is actually there is a gray area there. This right here, this Emax power supply is a 450 watt. One thing I do like about this one is it puts all the 12 volts out on a single rail or a single output, not splitting it up above the motherboard or the drives. And this power supply will dump 32 amps out to the 12 volts, so it's very nice. This one, even though it's 150 watts more power, only dumps 2 more amps, 34 amps into the 12 volt. It ends up just giving you most of the extra wattage in the 3.3 3.3 volt and 5 volt rail. This has a 40 amps out to 3.3 volt and a whopping 50 amps out to 5 volt. Yes, this can drive 5 volts at up to 250 watts. How these redundant power supplies work, and the reason that they're so expensive, is because they are multiple redundant power supplies in the same units. Also why server power supplies are very expensive when you try to buy them new, and why I was so coveted to find the used ones, especially on cheap from servers that have been torn down, because the chips and all the computer technology changes, the power supplies don't. And it's always something to remember. The power supplies always are outputting the same voltages, and these redundant ones are always nice. So if you have an issue where one of these power supplies modules fails, it doesn't actually take down the whole computer. When a power supply fails, it's a single module, and that's what they are. They are actually easy replaceable modules, and each, like in this one, each module is actually a 460 watts, but 450 watt module. And so if one fails, the other one is already running and just seamlessly takes over. But that's not truly what happens. Instead of it just taking over, when you have both modules in here, and these have buzzers that beep when one of the supplies fails, lights that flash, so they really let you know that there's a problem. As well as more modern ones will even tell the computer, so you can get notifications on your phone that you had a power supply failure. It runs each one at half output. It's sharing the load. And just so I was talking about where we could connect the 12 volt from this power supply to this one and have, in this case, it'd be a whopping 66 amps at 12 volts, which is getting to a dangerous level. They kind of share. One may lead the other a little bit, but as it approaches high load, its voltage drops a little bit, and the other one just inherently picks up the slack. So it runs each one at half output, so that the heat density, so not all 450 watts are just being carried by one of these smaller units. It's divided up, say at full output, 225 watts, 230 watts on each one. And they only run at the full output if there is a failure. Noise level goes up because, of course, the more load you place on a switching power supply, the noisier it gets, which is actually rather unfortunate. But that's the deal, it runs, and so these individual modules are pretty reliable because they're only running, even if the power supply is running at maximum output, each module is only running at half output just to reduce the heat density and to be a little bit easier on the electronics so they last a little bit longer. And whenever you have an issue, you just pull it out and pop in another one. I got the little latch there. There we go. And this has a little screw to lock it in. And then at the last note, a 50% redundant's a little bit different. If we pull one of the modules out of this one, this has 3 modules. One thing to also note is because these modules are redundant, there may be an issue. One of the issues may be somebody tripping over a power cord or power cord coming loose, so they don't use one power cord. These power supplies, each module will require its own power cord just to be truly redundant, even those situations where somebody trips over a cord. This one, you would actually have 3 power cords going to it. So that's always a little bit funky. And they do complain. It will run, if like this one would run with just one power cord, but it's going to act like it has a failed module and beep at you. Now this one, which is 50% redundant, even though it's a 600 watt power supply and this is only 450 watt, what we see here is the modules are a little bit smaller. And what's going on here is we can see that this module is only 300 watts. So what this does is does the same thing when all 3 modules are in here. It divides the load across all 600 watts, is putting 200 watt load on each of these modules. And if one module fails, then it will fall back onto any 2. So we could have them like this, or we could have, which way is this going? This way. So it could fail in that fashion, or maybe you could have the center one fail, and then all the power would be being supported by these 2 outer modules. And so it is redundant. If any single module fails, you can pull it out without even turning off the computer or anything. These are all Hotswap. You just pull it out, pop in a new module, and you're off to the races. But it is only 50%, meaning that it still needs 2 out of 3 modules to operate. Now, if you had an unfortunate situation where you're out getting a replacement for one failed module and a second module fails, then the power supply will shut down. The only caveat to that, and it depends on the actual design, is some of these that are like this, if it's actually running at below 300 watts of output, then it would indeed even be able to run off of one module. But say this was driving a 500 watt load and you already lost a module. If either one of these others went out, then the computer would indeed shut off. And so that's what a 50% is that they'll have an odd number of modules, like in this case 3 modules, and it needs 2 to continue to operate, where this is 100% redundant because each module is a full output module. And the reason they do that is because of economics. For like a 600 watt power supply here, it's cheaper to replace a 300 watt module than it is to replace a 450 watt module, or cartridge, however you like to call it. Anyway, I did want to provide some of that detail about server grade power supplies and how any of my viewers, I do a lot of tool reviews, but when you're working on electronic projects, really 5 volts and 12 volts is a real common voltage, and in automotive, all sorts of applications. And I've seen like these trip light power supplies and all these power supplies which are really expensive and don't really give you the kind of power that you're really looking for, which is dozens of amps, 20, 30, or even more amps, particularly out the 5 and 12 volt lines. And these server power supplies are a great way to do that, especially in a shop environment. These things are just super robust. Many of these power supplies have mean time between failures of 5 to 7 years. I mean, we're talking years and years of running full output, 100%, 24 hours a day, 7 days a week, 365 days a year. You're not going to find anything that is any more reliable than one of these, which can just be full bore, just into perpetuity, excuse me. And you don't have to worry about shorting them out or overloading or any of that, because they just protect themselves. They'll shut themselves down and set off alarms when you know you have a problem. And you have this great peace of mind of it being a redundant power supply. So if you have some kind of application where you need it to run for several days, and it might be critical that the item, whatever you're doing, doesn't shut off, can't be the redundant power supply, because even if a module fails, it'll still operate. Anyway, I'm sorry for this long video. It was supposed to be a short review, but I did want to talk about these power supplies. It's been a while since I dug these up. Anyway, I really appreciate everybody watching and subscribing. I promise future videos won't be quite as long. And if you haven't subscribed, please do subscribe to the Catus Maximus channel. Until next time, Catus Maximus.